Hello and a very warm welcome to Saurav Sir's classes. Today's tutorial will be on econometrics. In case of any query, you can contact us on this number, and if you wish to know more about us, you can check in our website. So, today we will be doing an exercise that is related to heteroscedasticity. So, let's get started. Now let us read the question. In a regression of average wages, W, dollars on the number of employees N for a random sample 30 firms, you have obtained the regression result. Now, the first question is interpretation of the two regression. So, let us interpret. Now, for equation 1, it shows, now we are interpreting this as N increases by a unit, on average, this is very important, on average wages increases by 0.009 dollars as it is given here, and if N is equal to 0, then W hat will be 7.5. So this is the interpretation of our intercept value, while this is the interpretation of our slope value, and this is for equation 1. Now for equation 2, we see that if we multiply the second equation through by N, then we see that we get quite similar result to equation 1. How we can say that? Because then we have W hat N 0.008, which is very close to 0.009, which was our slope value in case of first equation, and plus 7.81 by N, which is very close to 7.5, which was nothing but our intercept value in equation 1. So, after we multiply the second equation through by N, we get quite similar results. Now, next we move on to part B. So, the question is, what is the author assuming is in going from equation 1 to equation 2? So, in equation 1, we have this, and in equation 2, you divide the entire thing by N. Was he worried about heteroscedasticity? How do you know? So, let's answer this. So, I'll have to insert a page. So, this kind of method where you divide the entire, if this is my, so this is my original regression. Now, if I'll divide everything by sigma I, then I'll get something like this. Now this means this kind of, when from this equation I move to this equation, this simply denotes that I know sigma I square, and sigma I square is known, and that's why I am dividing each term by sigma I. That means I am applying a method of weighted least square. So in the equation itself we have seen that the entire original equation was being divided by a factor n. So this means, or we can interpret that author was absent and weighted least square is a method that is used in presence of heteroscedasticity. So we can say that the author was definitely concerned about heteroscedasticity, since he has divided the original equation by n, where n he has assumed, where he is assuming that the error variance is proportional to n square, and that's why, so sigma I will become n. So instead of sigma I in the second equation, to derive the second equation, everything has been divided by a factor n, which is the same approach as above. Okay. Now, thus the author is using which method? He is using weighted least square method for estimating equation 2. So yes, the author is actually concerned about heteroscedasticity, and that's why he has divided the original equation by n, where n, he is assuming n to be proportional to the error variance, and that's why sigma I in the next line becomes equal to n. And that's why, given this approach, we can say that sigma I square is known, and sigma I square, when it is known, we can apply weighted least square method, and weighted least square method is the method that is used for estimation of equation 2. So I hope this short tutorial on econometrics was helpful. If it was, please hit the like button, subscribe to our channel, and thank you so much for watching.